Hi guys, welcome to lesson 18.1. We'll be starting on page 315 in your book. And this one's all about geometric sequences. So there's a couple things we want to accomplish in this lesson. We want to be able to identify geometric sequences and the common ratio in a geometric sequence. And then we want to be able to distinguish between arithmetic, which you've been studying a little bit about, and geometric sequences. So geometric sequences are going to have a common ratio, whereas arithmetic sequences had a constant rate of change. So they had a common difference. They were going up by, let's say, exactly 2 every time. So that caused them to be linear functions because they had that constant rate of change. So let's find out a little bit more about geometric sequences. For her electronic communications class, Keisha has been tasked with investigating the effects of social media. She decides to post a video in cyberspace to see if she can make it go viral. To get things started, Keisha emails the video link to 3 of her friends. In the message, she asks each of the recipients to forward the link to 3 of his or her friends. Whenever a recipient forwards the link, Keisha asks him or her to attach the following message. After watching, please forward this video link to 3 of your friends who have not yet received it. One way to visually represent the situation is with a tree diagram. So a little vocabulary here. A tree diagram shows all the possible outcomes of an event. So here's a picture. The first starting place would be Keisha, and then she sends it to 3 friends. That's stage 2. Stage 3, each of them sends it to 3 friends. And so you can see it triples every time. So using the diagram to help us, we're going to complete this table here for number 1. At stage 1, it's only Keisha that watches the video. So on stage 2, it's 3 of her friends that watch the video. And on stage 3, it's 9 people, 9 new people will watch it. And then they're going to each send it to 3 friends. So on stage 4, there's going to be 27 people who see it. Hopefully you could have pictured that and figured that out. So expressing regularity, the patterns that we see is each stage is 1 more, but with each stage, the number of people, it's not 3 more every time, but it multiplies by 3 or increases by a factor of 3 each time for each stage. So this is just increasing by 1 each time, but the number of people is multiplying by 3. It's increasing by a multiple of 3. So then they want us to use our table to graph it. So on stage 1, there was just 1 person. Let's see, this is going by 5s up the side, so maybe that'll be about here. And on stage 2, there were 3 people. And on stage 3, there were 9 people. And then on stage 4, there were 27 people. And I guess we could figure out how many people there would be on stage 5, but I think it'll be off the graph because 27 times 3 is going to get us beyond 50. So is it linear? No, it's not linear. It doesn't have a constant rate of change. Plus you can see from the graph that it's not a line. So even though it changes by a factor of 3 every time, that doesn't mean it's changing by a constant rate. Because right here it went up 2, but here it went up 6, and here it went up 28. Nope, 18, sorry. So you can see it's not a constant rate of change. So this is going back in our heads a little ways, is the graph of function. So if we look at the graph that we made, do you remember how to tell if it's a function? Every input, and they even remind us here, every input can only have 1 output. So it would pass what? Do you remember? Hopefully you're thinking, I can't hear you, but hopefully you're saying a vertical line test. So this would pass. So yes, it's a function. Yes, a function. That's not a good sentence, but yes, it's a function. What's the domain? So the domain It starts with Keisha, so it starts at 1 and then it goes up by 1 every time. So those counting numbers, not including 0, 1, 2, 3, 4, 5, 6, you can say all whole numbers not including 0, or you could say natural numbers. That's what those are called. The domain is all natural numbers. Natural numbers are all of the counting numbers starting with 1. So it doesn't include 0 or negatives. So then it says the number of people who have received the video link at each stage form a geometric sequence. And then a definition here for you, a lot of vocabulary. A geometric sequence is a sequence of values in which a non-zero constant ratio exists between consecutive terms. The constant ratio is called the common ratio and is typically denoted by the letter R for ratio. The common ratio is the value that each term is multiplied by to get to the next term. So write the numbers of people who have received the video as a sequence. So it went 1, 3, 9, 27, and then it continues like that. So we're supposed to reason quantitatively, identify the common ratio, justify your response. Can you tell what each thing is getting multiplied by every time? I think we already sort of said that. The common ratio is 3. And each subsequent term is 3, that's 3 times the term before it. So each term multiplies by 3 to get the next term. So now we're going to take some sequences here, which are just lists of numbers, and we're going to identify them as arithmetic, geometric, or neither. If it's arithmetic, we're going to state the common difference. If it's geometric, we're going to state the common ratio. So just to remind ourselves from the past, an arithmetic sequence is a sequence in which the difference between consecutive terms is constant, like a linear function would be. So this difference is called the common difference. So if it changes by the exact same amount every time, that's arithmetic. So let's look at A here. It goes from 5 to 8. That's going up 3 more, up 3 more. So that is arithmetic. It's spelled like arithmetic, but it's pronounced arithmetic. And the common difference is 3. So this one here, it goes from 18 to 6, so that might be minusing 12, but then that doesn't work here. So it's not a common difference. It might be dividing. Let's see, if I divided 18 by 3, I would get 6. If I divided 6 by 3, I would get 2. And if I divided 2 by 3, I would get 2/3. So this is geometric, but we just said that geometric is something that happens when you multiply by the same number every time. So what would I have to multiply by? What would my ratio be that would cause me to divide by 3? So I have to put it in terms of a factor, something I would multiply by that causes my term to divide by 3. Hopefully you're coming up with 1/3. Because if I multiply a number by 1/3, let's say 12 for example, I'll just come over here. If I multiply 12 by 1/3, that means I'm multiplying 12 by 1, so it stays 12, but I'm going to divide it by 3. So in order to divide by 3, we have to multiply by 1/3. So let's see, on C, we are, it's going up 3, but then it's going up 5, so it's not a common difference. In order to multiply, to get from 1 to 4, I'd have to multiply by 4, but 4 times 4 would be 16. So this is neither. It's not multiplying or adding. When I say adding, remember that could mean adding or subtracting, because it could be adding a positive or negative difference. And then for geometric, we'll say multiplying, but remember, it could look like dividing. You would just have to multiply by a fraction. All right, so let's see on D. In order to get from -1 to 4, we're going to add 5. But adding 5 to 4 is not going to get us to -16. So let's see, if I multiplied, in order to get from -1 to +4, I would have to multiply by -4, right? -1 times -4 would give me +4. +4 times -4 would give me -16. and negative 16 times negative 4 would give me 64. So that looks like it is geometric, and the common ratio is negative 4. If you see something going back and forth between negative, positive, chances are it's a geometric sequence that has a negative ratio, so it's jumping back and forth and back and forth. So let's see, 16, letter E, 16, to get to negative 8, I would have to minus a whole bunch, but then I couldn't minus something to get to 4, so it's not arithmetic. If I took 16 and I divided it by 2, I would get 8, but I wouldn't get negative 8. So if I took 16 and divided it by negative 2, then that would work. I would get negative 8. And if I took negative 8 and divided it by negative 2, I would get positive 4. So I think I need to divide by negative 2. So if I want to divide by negative 2, what would I have to multiply by? I think it is geometric. And the ratio is, we want to divide by 2, so multiply by 1 in order to do that. But it needs to be negative. So negative 1/2 would be the ratio. All right, so we'll pick this up in class. The important things for you to be able to do are figure out what the ratio is, even be confident with fractions or negatives, like to make it work, and then be able to tell the difference, describe what is an arithmetic sequence, what is a geometric sequence, and then be able to tell the difference between the two so you can identify them. All right, we'll see you in class.